Hello. Good morning, everyone. On behalf of Laura Spagnolo and Tom Burnley and I, we welcome you to the start of the CCP-EM Spring Symposium. I hope you are, as I am, looking forward to the next 2 days of exciting presentations, highlighting the ever-growing and diverse methodologies and discoveries in cryo-EM. I also hope, whether this is your first or your umpteenth CCP-EM Symposium, you continue the tradition of camaraderie and open discussion that is so special and makes CCP-EM Spring Symposium such a great event. Please also don't forget to place your votes for posters. The first poster sessions closes at 2:30 today, so make sure you hand in your voting slips at the reception. Before we start, we should thank Lauren Giles at STFC, who's the driving force for organizing this meeting and doing all the hard work to put it together. And also Stuart Ayres and Jonathan Alderfield for the IT and AV support, digital support that goes into the meeting. And I'd also like to thank our generous sponsors from companies in our field whose innovations catalyze our science. So that's CryoCloud, Dexterous, Hammerspace, Nanosoft, Nuclera, SPT Labtech, Sub-Angstrom, and Thermo Fisher Scientific. And so that's all for me. And so I'll firstly welcome to start this session on what's new in CCP-EM, Colin Palmer, from CCP-EM.
Thank you for the introduction, Renee, and thank you all for coming. It's, as always, a pleasure to be here, and it's always a lovely conference. It's nice to see a mix of familiar faces and new faces, so welcome to all of you. Falls to me this year to give you our annual update on what's been happening in CCP-EM, our project. Well, to me and to Rangana, who's going to speak afterwards. So a quick overview. I'll just briefly mention some of the workshops and events we've been involved in, because that's a large chunk of our work, and then I'm going to spend most of this talk telling you about some of the software that we've been working on in the last year. So on the workshops, we've, as usual, contributed to quite a few workshops in the past year, teaching people how to use our software, how to process their data. That includes workshops that we run ourselves and organize, such as the ICNIL workshop. Agnor is sitting over there, always puts in a lot of work to organize that one. And then various other workshops, often organized by other people, where we can just contribute some sessions and help run things. One thing I wanted to highlight is we've been running these, what we're calling Doppio roadshows in a few places already. So this is where we go out to different people's facilities and we help get our Doppio software set up and running on those systems, maybe give a talk or a tutorial. So I just want to say, if that sounds like something you would like to happen at where you are, please get in touch with us. We can try and arrange something. And I thought I'd also highlight some of the upcoming events we've got. First one is two kind of more specialist meetings. Next week, we have our CCP-EM Working Group 1 meeting. This is open to all UK-based researchers at PI level or equivalent who have an interest in cryo-EM. So hopefully you've already heard about that and been invited, but if you think that applies to you and you would like to be there and you haven't heard about it yet, please get in touch with me or with Tom Burnley or with Lauren on the registration desk, and we'll make sure you get the details. The other one is a EM facilities meeting, which is going to be hosted at the University of Warwick in June. Again, we've reached out to try and contact people we think should be involved in that, but if you would like to be involved as well, again, please contact us. And our involvement in other courses doesn't stop. So we're going to be running our ICNIL workshop again in October. We're going to be involved in a couple of other workshops that are coming up in Padua in Italy in July, and the EMBO cryo image processing course in Birkbeck in September. In general, just keep an eye on our mailing list and you'll find out all the details of those as they come up. But do consider coming along if you want to learn more about how to use the software I'm now going to tell you about. So I thought I'd start with a brief recap and overview of the way our software is structured for anyone who's new to this. Those of you who were here last year would have seen our kind of initial release of the first stable version of this new software we're calling Doppio, which is our kind of in-browser web-based user interface for CCP-EM. we tend to call the whole thing Doppio, but actually it's broken into kind of three parts. Doppio itself is just the GUI layer that sits on top. Then there's this pipeliner layer in the middle, which is kind of project and job management, and then all these individual jobs. Just to mention a bit more about those, Doppio, the GUI is written in JavaScript, so that means it runs in a web browser. It can also run in a standalone desktop app, so you can just use it like a traditional desktop app if you want to. That's distributed under our own kind of CCP-EM license, which is free for academic use, and details of that on the website. The pipeliner layer in the middle, it does the project and job management. That's all written in Python. It's all fully open source, and it uses this graph structure for the project, which crucially is kind of fully compatible with Reliant 4 and 5. So the idea is you can go back and forth between Doppio and Reliant in the same project and everything will just work. And then the layer at the bottom is all the different pipeliner jobs. These are kind of written with this extensible plugin architecture. So they're all little Python modules that sit in the pipeliner, but then they call out to other software, which can be written in any language and under its own licenses or whatever. So that's the basic structure. I'm now going to take you through some of the new developments we've made in the last year since we announced it. And if there's time at the end, I'll give a brief demo as well. So, as I mentioned, last year we made the first stable release of Doppio 1.0. Told you about that. We're now releasing what we're calling version 1.3. This is well, we've made a couple of updates in the last year, but 1.1 and 1.2, those are still available on the website. We've put some major developments in now for 1.3, so we're calling that a beta version. So it's still reasonably well tested. We're quite confident in it, but there's slightly more chance of bugs in some of the new features. So we encourage you to give it a go, and do please just let us know if you run into any problems. On the Doppio GUI side, we've made a few developments, which I'm going to tell you about. The main aims of which are to make Doppio easier to use, easier to install, and also to reduce the need to step out and use other tools. So trying to be able to do more within the web browser without needing to step out, which is both kind of convenient when you're working locally, but it's particularly important if you're working remotely, where it might not even be possible to launch another tool without kind of running some remote desktop or setting up a separate SSH session or whatever it might be. So trying to streamline things as much as possible so you can do things in the browser. So the first thing I want to tell you about is that we've switched to packaging Doppio using Conda instead of our previous method. I'll tell you about that in a moment. But first, just wanted to clarify some possible confusion that comes up around Conda. So what is Conda? Conda itself is just an open source cross-platform package manager. So Conda is just a little tool that allows you to set up environments and install other software on, it'll use it on Mac and Linux. It also works on other systems. Where the confusion comes in is that there is a confusing mess of terminology and licensing requirements around the Conda kind of wider ecosystem. So Conda as a tool is fine, but there's lots of the other things, Anaconda and different Conda channels and Mamba and MiniForge, lots and lots of names that are extremely confusing when you're first getting into it. We've taken care of the details in the way we're using it in Doppio. Just to mention, if you're using these tools yourself, you just need to be aware of some of the pitfalls and pay attention to the licensing details. And in particular, I've seen some people recently say kind of, oh, we can't use Conda anymore because Anaconda are tightening up their licensing requirements. And that's overkill. Kind of, you can still use the open source bits perfectly fine. You just need to be a little bit more careful. So we've decided to move over to a tool called Conda Constructor. We were previously using PyInstaller to package Doppio, which bundles a load of stuff together into a single executable and makes life very easy for making something you can install and run. But it was a little bit limiting, and so we've moved across to this Conda Constructor option instead. Main reasons for the move are to get a full Python environment, including that pipeliner layer I told you about. Previously, that was kind of bundled inside a single file in Doppio and hard to access. Now it's there as a full-fledged installation, so you can run all the pipeliner's command line tools and scripting, easy to add extra libraries into that, easy to debug its configuration. As a bonus, it also enables us to install lots of additional packages quite easily, so I'll show you that in a moment. As an end user, there's not really much difference except the way you install Doppio has changed. Previously, you had to unzip something. Now you have to run, well, on Linux, you have to run this shell installer script. On a Mac, I think it's just a package that you just drag across into your applications, if I remember rightly. I'm not a Mac user, so I don't know the details. So the installing additional packages is hopefully going to be a useful feature for many of you. This is a new page in Doppio where we have this list of packages that we know how to install. buttons to install them. You can just find it in the project home menu here. The idea of this is you can just do one-click installation of additional packages, each of which goes into its new own isolated Conda environment. To emphasize, this is not exclusive. It doesn't replace any of the kind of old ways you could set it up. So if you've got an existing installation of the software and you want to use that, you can still just use that the old way. But this hopefully makes it much easier, particularly if you're using Doppio just on a single laptop or something. You can just install it. You can click a couple of buttons in here to get some of the tools you want to use, and that will make life much easier. As I said, these are all beta features. This is an early stage. We will be making improvements to this rapidly in the next few months. One of the key things we recognize we need to add is more and clearer information here to kind of tell you, like, if you install this package, which jobs will that enable you to run? And if we do find multiple installations, like someone's installed something with Doppio and there's a separate version on the system, which one is it going to use and how do you control that? We also want to add more packages in. A crucial one is rely on, of course. People do find it a bit of a pain to have to compile and install that themselves. We would like to be able to install that using this mechanism or bundle it with Doppio. We haven't quite figured out the best way forward yet there, but we do have it high on a list of things to make easier for people. Right, moving on to some of the other GUI tools we've put in. One of these is an in-browser class selection tool. So this is the work of George Coldstream in our group. So this allows you to view the results of a classification job. So we've got our usual 2D classes here. It also works for 3D. There's this new select mode button at the top. You can click that to turn on the select mode, select the classes you want, and then run a new selection job based on those. So there is no longer any need to step outside Doppio and run the old relying selection job if you want to select the classes you want to work with. The other major new development we've added is an image viewer. I'm not going to go into too much detail about that now because Rangana's got some examples in his talk as well, which you'll be able to see. But the idea of this is it's now an in-browser interactive image viewer. Previously, we displayed thumbnails, little snapshots, examples of images in your project. Now you can browse through things properly. So you can browse through your entire data set. You can slice through volumes. So this is now looking at a slice through a 3D reconstructed volume. You can view related data. So for example, CTF diagnostic images or particle coordinates. Again, this is early, so we've rolled this out to a few of the jobs. There are more places we could make use of this, so we're going to continue rolling that out to more of the jobs. We would like to add a manual particle picking option, so you can add and remove the particle coordinates. Particularly, that's going to be useful for the tomography pipeline that Rangana is going to tell you about. And we'd like to be able to have zoom and contrast control, so you can really get to grips with the detail in your images more if you need to. On the pipeliner side of things, so this, again, if you're using Doppio, this all feels like it's part of the same software, but if you're using it from the command line or the kind of the fully open source version in the pipeliner alone, then the difference is important. We have some new jobs. So a couple that I'm just going to mention, which are also highlighted elsewhere. So jobs called CryoDAN and CryoVAE. That's the work of Sonia Malhotra in our group in collaboration with Yuri Chaban. They're for particle denoising and filtering. You can see an example of the output over here. And Yuri, as I think might mention it in his talk, or certainly is on his poster, it's number 60 in session 2. So do take a look at that if you're interested. We've also got new jobs now for Servalcat atomic model refinement, a tool called Metal Coord and ProSmart, which are both for generating restraints to help go along with that refinement. And Martin Malley has done a lot of the work on that, and he's got a poster here as well, which is number 80 in session 2. So again, if you're interested in the details of those, go and have a look. I'm going to mention a little bit about the CryoDragon jobs we now have as well, and Rangana is then going to give a short talk about the tomography pipeline. And then there's a couple of other new features related to existing jobs that I thought I'd mention as well. So just briefly to mention the CryoDragon ones, Joel Greer in our group has been working hard to implement these on the pipeline side in collaboration with Ellen Zong's group at Princeton. So we have jobs now for running CryoDragon 1, which does heterogeneous reconstruction from refined particle coordinates. We've also got jobs running CryoDragon 2, which is the ab initio homogeneous and heterogeneous reconstruction algorithms. And we have a way of launching CryoDragon's built-in interactive subset selection tool. So you can now kind of visualize the latent space that GrowDragon produces for where your particles are distributed in kind of conformational space, and then you can use the interactive selection tool to select the ones you want or filter out junk, and then make a selection and do a reconstruction from those. So it's all kind of built in and should work nice and smoothly. A couple of other new features to highlight. One is these model validation percentile scores. So in general, the model validation job that is largely the work of Agnel Joseph has been improved. It now does more scores. It has more guidance in the output results to tell you what the scores mean, what the good values are, what bad values are. And one of the contributions to that is a heroic effort by Agnel to calculate all of these scores for all of the cryo-EM structures in the PDB that have half maps associated. That's a requirement because the half maps are necessary to calculate some of these scores. And so now we know the distributions of these scores across all of these existing structures. And so now we can give percentile rankings. So if you calculate, validate your structure, you can now see on the percentiles, how does this compare to other structures? And if the resolution of your structure is known, it'll compare in a given resolution range. And if it's not, then it'll just do across all resolutions. So I don't know how we can read this table here, but as an example, this is one I ran on our tutorial data, and you can see that the FSE average is up at the kind of 92nd percentile, and the guidance tells us that below 25 is bad, higher numbers are better. So this is a pretty good structure. We can look down and we see percentiles for the clash score and the non-probity score as well. We don't have percentiles for all the scores, but you can see there is now kind of guidance on what is recommended for many of these. This is now very helpful when it comes to validating your structure and understanding if you've done a good job or not. The other new thing to highlight that is still in development are these deposition tools. So we've been working hard at this. Is mainly the work of Matt Yodanza in our group in collaboration with people at EBI. So these are two different ways of helping you to ease the process of depositing your data into the public databases. For EMDB, this is still in active development. The idea of this is it's going to allow you to associate imaging and microscope metadata with your imported files when you bring them in, which will help kind of keep track of things all the way from your microscopy session through to deposition. And the idea then is that from any of the jobs in Doppio, you'll be able to say, I want to kind of deposit the outputs of this, and it will collect all the necessary metadata into a CIF file. You'll be able to provide that CIF file to OneDep, and it will pre-fill a lot of the information in the form for you. Final details are still being worked out. It's still being developed. I think Carl and Matthew might have a little bit more to say about this in their talk as well. But we are working hard on this, and it will hopefully be available soon. The Empire job is already there. You can now use it. This is a separate job in Doppio that you run. You tell it to prepare a folder for you, and it will copy all of the files that you want to deposit into Empire into a suitably arranged single folder that you can then upload to Empire. You will then need to go ahead and use this Empire depositor script that you can download separately to upload that folder, and you need to contact Empire first to arrange a deposition token to use. So that's a little bit more involved, but it should ease one of the steps in the process of actually preparing the data that you want to send up. That is all I wanted to say from my slides. I think I've got a couple of minutes spare, so I might just give you a very quick demo of some things live in Doppio. But before that, I wanted to acknowledge CCP-EM is a big collaborative project, so we have a lot of people to thank who are involved in this work. The CCP-EM core team do a lot of the software development work. We have this wide network of collaborators who contribute these fantastic algorithms that we use. And obviously also we want to thank all our various funders who have contributed to the various different bits of the work as well. So I will now step out of this and give you a very quick demo, and then I'm going to hand over to Rangana, who's going to tell you about the tomography pipeline. So just to show you what let's have a look at some of these new tools in Doppio. So I'm just going to start up Doppio, the web browser version on my computer. This is just the standard 1.3 beta version that's available on the website. So I've come into Doppio. I can show you this install additional packages feature. We got time to actually. Oh, you can't see it. Ah, okay, wrong screen. Thank you. Good. Okay, so this is the install additional packages feature, which you can now find in the project menu. Let's try and install a new one. Why not? So as an example, I'll use EMDA, so I can search for EMDA in my jobs, and it says, oh, there's no jobs available. I can click to show unavailable jobs, and it tells me, we do have an EMDA mask creation job. If I click on it, it says it's unavailable as it can't find the right executable. Okay. So if I want to fix that, let's see if I can that by installing the EMDA package. So I'm just going to click this install button here. I'm going to go away and or in the background and install some things. While it's doing that, I'll go and show you some of the other features, and we'll come back and check how it's gone in a minute. So let's have a look at some of these model validation scores. Look at the model job results. So here you see these percentiles. One thing I didn't mention is that in some of these you can hover over and get help text that tells you a bit more. Viewer, because that's quite nice to see. So previously, when we had a 3D volume, we displayed these kind of 3 orthogonal slices. They're still there, so you get a quick overview of what the result is like, but you now have this image viewer as well, so I can step through and actually view the slices through my volume. So and you can see that running locally on a laptop, at least, this is quite snappy. The performance isn't bad. I briefly saw there, I don't know if you did the pop-up at the bottom that said EMDA's finished installing, so let's go and have a look at that. On the additional packages, you see EMDA is now says it's installed. And so if I now go and look in my jobs, I should be able to search for EMDA again and should now find that job is available. So yes, now I could run EMDA. So it is as simple as that to install a new tool and be able to run jobs in it. That's about all I have time for. I should hand over to Rangana, so he's got time for his talk on the tomography pipeline as well, but that's just a bit of a flavor of the new stuff in Doppio. One other point I wanted to mention is we've got a desk here along with all the exhibitor stands. There's a CCP-EM desk, so if you have any questions or you want to come and play with it or see it in action, do just come by to our desk and come and have a look.
Hello, everybody. So it's tomograph time. I think you can hear me with this one, right? So this is something we promised for 2 years or so. So finally, we have it here, tomography pipeline in Doppio. So that's a very exciting news here. So we have, we can say that we officially released the first version of tomography in our Doppio pipeline. So today, what I'm going to do is I'm going to walk you through about these new developments and so how you can use it, what are the capabilities and so and so. So this is a collaboration work between CCP-EM, MRC LMB and University of Pittsburgh. I want to thank SHORS and SAC for their immense help to achieve this task and their guidance and allocating resources and various ways. So it was very fruitful collaboration. So let's begin. Tomography. We know tomography is an incredibly powerful tool. So it allows us to see the molecules in their native cellular environment. And also it's essential for understanding heterogeneous and flexible components or complexes when the SPA don't quite well work. But it also comes with certain challenges. So I have mentioned it only a few here. So for example, we know the tomography workflows are essentially relatively complex than SPA. So it involves scripting and manual metadata handling, and there are other things as well. So that essentially means that this has a higher entry barrier for newcomers. And also it has bottlenecks like particle picking and so on. So things are coming good now. People are working on various bits of these problems. And also the last bit, remote processing moves. So this is common for both SPA and SPT. STA pipelines. So, you know, so if you are running remotely, you know, the waiting game. So that's a common thing. So these are the exact problems that we are trying to address in our CCP-EM tomography pipeline. So we have embedded or integrated these tomography tools, Reliant tomography tools now into Doppio pipeline, so you can run them with in a modern user-friendly interface. So by doing that, we have increased the usability that you are on the browser. By doing that, we have lowered the bar so that newcomers are welcoming now. And also, we have integrated some of the other picking features. So things are also coming. We are integrating more and more such tools. And also, as Colin mentioned, Doppio has a dual action modes, a desktop mode and also the web browser, web-based mode. So if you use the web-based mode using port forwarding, you will feel like that even if you are processing your data in a distant remote cluster, you can just log in and do the processing, and you will feel like that you are sitting really in front of your HPC. Let me show you the brief, the high-level overview of our pipeline. So this is exactly the Reliant tomography pipeline, but now in Doppio with enhanced metadata capturing and remote-ready workflows. So the workflow starts with the tomogram generations, where you import the data and do all the corrections like motion correction, CTF correction, and alignment, and so all the way to reconstruct particles. So you can run all these steps now in Doppio. So if your end goal is to do the subtomogram averaging, next step is the picking. So you can do the picking in your favorite software, or so we have support for Napari-based picker that Alistair developed. So we have encapsulated that Napari picker into the tomograph Doppio development. Once you have pick particles or pick coordinates, then the next thing is to do the subtomogram averaging. We have started with extracting subtomograms, refinement, classification, all the way to the end density of the post-processing step. So you can run all these things in Doppio now on a nice web-based GUI. So by doing that, we enhance the metadata workflow, metadata capturing. So we make sure that the metadata flows through in each step, in all stages. So this is a centralized system that's very good for the reproducibility of your work, and that's something really need for in a collaborative or publication setting. So let me show you what we mean by plugins. So in the previous slide, I showed all these steps, but for all these steps, we communicate between Reliant and the Doppio. So the communicating component or the module is written in using Pipeliner. So we call it Pipeliner plugin. So how Pipeliner plugin works, it's relatively bit more complicated than what I show here, but for the moment, let's assume that it facilitates the communication between Reliant and Doppio. So it captures data, it allows you to input parameters and so, and then it outputs results, and so everything is done in this Pipeliner plugin. So the key advantage here is that the parameters and metadata flow automatically between steps. Also, it's incredibly easy to combine these Pipeliner plugins with other CCP-EM workflows. So if you want to combine your own software into the Pipeliner, into the Doppio, so what you have to do is that you have to write a small plugin. So it's very easy, straightforward thingy, and then you can run your software within the CCP-EM Doppio framework. So on the right side, this is one example in action, this Reliant tomography reconstruction. So the people who have used Reliant for this job, the parameter set looks familiar here, but it comes with Doppio enhanced metadata capturing and remote processing capabilities. And the next thing here is that our new image weaver. So we know tomography is essentially repetitive. So you do bin 1 refinement, bin 4 refinement, 2 refinement, and so on. So sometimes you need to start from scratch. And so this is a very iterative process. So you have to make sure that you are on the right right path to your final results. So how you do that? Basically, you make sure that you want to look at. Oh, I can see it here, right? So you want to see the intermediate results in each steps. So here's an example. In our image weaver, we have plugged in our image weaver for the CTF estimation job. That with that you can see how the power spectrum looks like, the power fit looks like in the compared with the tilt image. So similarly, these two steps, alignment, oftentimes you want to see how your alignment goes. So it is good or bad. So by looking at the align tilt series. So in our image weaver, you can see how the alignment looks like, and it gives you a good feeling and confidence on your final results. So also we want to look at the tomogram inspection, tomogram. So once you generated the tomogram, you want to see how it looks like. You see whether the components you want to see in your tomogram, or it added some artifacts. So in those cases, you can use our image weavers. It's everything in real time. It's all good, and you don't need to jump into iMod and back and forth. So now everything in one browser and one image weaver. As I mentioned before, so we support Napari picker in our Doppio pipeline. So this is how you launch it. So you go to new jobs and just type Napari, choose the picker, and then give it the necessary file, in this case the tomogram file, choose the picking mode to spheres, for example. This is for capsid data, and then just hit the run button, and that will open up Napari, and you can change the contrast as you like, and the next thing is to place the capsid or the sphere. Let's wait here, and then resize it as you want, and you can change the color if you like. Basically, that's it. You can then make it's nicely centered, and finally you save the hit the save sphere button, and then quit. So that job is done, and you will see the particle file. Right. So not only Napari, we have also integrated another tool called Eulermate. So this is important for when you want to do the context-aware picking. So what we mean by context-aware picking is sometimes we want to pick particles with their context. If it is on a membrane, or if it is in a filament, we want to pick particles relative to that in surface. So in that cases, for such cases, the Eulermate is a good tool. So in this case, what we essentially do is that, so for example, in this case, you see it is a synapse here, and we wanted in this case, we wanted to average the synaptic linkages. So we pick them in iMod as a line across these two membranes, and say the iMod particle file is .mod file, and then you pass through that file in Eulermate in Doppio, and the Eulermate will prepare convert that mod file into a Reliant style star file, and it will assign the Euler angles as well. So then you can open those star files, for example, in any in particle weavers like RTIX or oblique. So in this case, what I shown here, RTIX. So that gives you a feeling that, okay, so my alignment is correct and this is good enough for my initial model generation. So that's how it works. So I must also mention that the first version of this was written by similar code was written by Miles Graham from Struby. So that inspired me to write this Eulermate tool. Now it's in our Doppio pipeline. All right, so to recap, so we have integrated tomography pipeline into Doppio. Now it's ready for the first release, so you can try it and give us some feedback. And also the pipeline plugins for Reliant tomography jobs are there, and they are now first-class citizens. And I presented some examples for our tomography weaver and the Eulermate weaver in the case of context-aware picking. So what this means to you, actually, so we are trying to make the tomography easy thing to do, and we will continue to build. And we hope that what we already have is good enough to make the tomography smoother and powerful user experience. And finally, I want to thank all these people, CCP-EM, all members of CCP-EM group here, the people, the dark purple or blue, I don't know. So those people are tomography figures. Nick, Yola help develop the tools, tweak the code, and do so many tests. So it's a very good thing. And for George, our new image weaver guy, and Matt, so he helped in various ways with the code and integrated tools, writing some plugins and so and so. All right, all other members as well. I want to thank Bogdan from LMB. So he also helped testing the plugin. Alistair, he will talk about his walkthrough on Friday. So he helped me understand in my early stages into this tomography, and also Ian Pyle. Jonathan from CZI, so he also helped us writing some tools, and also from Pittsburgh, they prepare data, send us so many data, so it's very nice. We can play with all these things. Finally, the group, right? I think we need a bigger cycle now. And our commercial partners and funding people, right? That's all. And so if you have questions.
Thank you, Rangana and Colin. Do we have any questions?
The progress is great. I like it very much. You're still using Napari for some of the job types, and in our hands anyway, Napari works very badly or not at all over the network. Is there any plan to move the Napari job types internal in the same way you've moved the class pickers internal?
You want to say something?
You guys.
Okay. So in terms of tomography, so Napari, so the web-based interaction, Napari is not the greatest tool, so it's very heavyweight. So what we are planning to do is that replace Napari with our own picker that we are developing the image weaver into the picker.
Is that the same for things like the dynamite analysis tools?
dynamite analysis, do you know?
Yeah, I think in the long run, we would like that. It's that one in particular is not is one of the things further down the list compared to getting, say, the particle picking in the tomography, which is obviously a kind of key step in the process. But yeah, in principle, we would like to expand the image viewer to kind of handle all of these cases whenever you need to annotate an image or a volume with any kind of information.
Any other questions?
Really nice work. Particle picking and for subatomic averaging, it's very tricky. It's very much project based. So far, we haven't found anything universal applied multiple projects of using same method. So yeah, I don't know whether there are better way to do it or not. I don't know. That's one. Another one's a particle pickings also depend on how good the tomogram or T series element is. And right now, this is still MOD based T series element or use ARE tomo or what is the T series in the pipeline? This is actually rely on T series element.
The tilt series.
The reconstruction.
Yeah, T series element.
Tilt series alignment. So the example that I showed, actually the pipeline plugins has for iMode and also for Atomo. So those are the two programs that we use for the tilt series alignment.
And is a template matching also available?
We don't have yet the template matching routine integrated into Doppio pipeline, but we will. So that's in our plan.
Great question at the front there.
Is it better now? Okay, yeah. I have a question for the web apps. So I think it's a common practice to also have a Docker container provided. Do you have any plans to implement something like this for Doppio?
We don't have specific plans for that yet, but if there's a use for that, if you have a need for it, then please get in touch and we'll put it on the list.
Because this one, the current architecture more looks like that it's tailored towards like a standalone GUI still, but I think with the web interface, there is much more flexibility that one can achieve with a container. Thank you.
Great, thank you very much.
George has a question on that.
Oh, is there? Where's that? On the left.
I want to echo Pijun's question, how important it is that there will be multiple pickers implemented in Doppio. And I think, CCP-EM team can do this, but if people have their favorite picker, you can also write these plugins yourself. As Rangana explained, it's not so much Python code to write a plugin for the whole Doppio pipeline, and the CCP-EM team could help. I think this is one of the whole reasons why you would do this kind of general platform anyway with plugins. So because there's so many different pickers for so many different applications, and this could be a great way to kind of combine those into a single worker.
Can I ask a sort of related question? If you wanted to, instead of using Atomo or iMod, reconstruct and use WarpM in your pipeline, how would you recommend doing that through Doppio or integrating the two?
So I think I must say that I have not tried pipeline yet by myself, but I think so some of the components can be brought into our Doppio framework using pipeline plugins. So that we need to test actually.
Great, thank you very much. So let's thank again Rangana and Colin for the excellent talk.